Alright, I've got some information that I think may shed some light on this. This is the Mitchell-Hedges crystal skull. And there's been all kinds of speculation. It's a fake, it's this, it's that. Well, who knows? But I do mud fossil research, and that means that the mud fossils are creatures that have turned to stone, that were literally creatures, and now they're stone. Now, I find crystal creatures as well, and the reason they're crystal instead of like rocky stone is that they're in hydrothermal areas, and those kind of areas vary between highly hydrothermal, which they're hot and boiling and all kinds of things going on, and sort of clear, gentle boiling. And what it does is it boils the mineral stuff out of bones, I mean the organic material out of bones, leaving minerals that end up getting attached to the invading molecules. And in this case, it appears that it was literally almost clear water, and it ends up being a molecule normally, like I believe it's OH minus, that invades and is highly ionic and ends up being fairly clear and creates like a quartz situation. Now, I want to show you what the actual human brain looks like. That. Now, before I do that, I want to just mention that all of the vascular stuff in humans or in creatures, they're made to keep the blood in that tube and everything else out. There's all kinds of layers. There's sheathing, and there's all kinds of things. There's fascia, and it creates this literally impregnable tube. Now, I find in the mud fossils that they are the way I can tell of any type of mud fossil, that what it really originally was by the vascular network that is there. Usually the shape and everything is still correct in most of them, or in a lot of them. But sometimes they're distorted and crunched up and things. But you can still see the veins and arteries because of this particular nature of the matter. Now, you see all these stripes in here. Now, this is literally, and you see where they all tie in, sort of, they fuse in together, and look around the jawbone, you see these little tiny holes and so forth. These are all, and this jawbone is articulated and comes away from this. And it's quite an incredible a feat if it was made by someone, and I don't think it was, because all of this articulation and the neural pathways are virtually identical, and here's what they look like in the human. Now, this is the same orientation. The guy's forehead is here, the back of his head is here. Now, remember all these stripes here, these pathways that ran up here, and then another chunk that ran out the back. Look, here it is. It's so clear. You see, there's that chunk that runs out the back. Here's all the pathways that run up the middle. Then look at this, how it blossoms out this way. And you know, it could have created a space in here between what the brain, the actual brain tissue was, and this filled with just a clear fluid, or this could literally be a part of the brain. And here's what you're going to see. Remember all this striping things here, and then all this stuff going up to the front to service the front of the brain. You see it? Look, it's the same thing. Here it is, all that. Now this here, remember, it squishes out into the back. Now, if the guy was laying on his forehead, this would come away and you would have an air pocket here, but you would have this looking bristly effect, which is exactly what you have. All right? Now, look at this vascularization here. You see these little pockets and so forth that are on here? That is what happens when when bones get boiled out, and everybody probably knows this. Now I'm going to show you something that I did. I created some of my own mud fossils, and I did a bunch of experiments. Now, this was, let's see if I can make this a little more clear. This was boiled out in and electrified in copper solutions. And you see the vascular network here. Hold on, I think I have a better one here. All right, this one here is the same experiment, and you can see it did turn into. It started to change the mineral, but anyway, what we're looking at here is this little. Those are the spongy bone, and there's the outside of the bone. Now, there's other conditions where where this same looking structure is a porosity is there, and then the tendon fibrils actually invest into there, and I have lots of images of that as well. But the tendon fibrils hold the strappy muscular tendon, you know, the tendons and the muscles and so forth, to your jaw muscles. That whole area there is replete with investments of your jaw muscles, your mandibles. They pull it back and forth here. There's a tremendous amount of muscular investment in here. Everything looks exactly like it should look. I can't find anything that looks wrong here. That's all I can say, and I really don't have I don't have enough to go by. What I would like to see, really, is the underneath here, because this will have been serviced by blood. And there should be some little, sometimes it's very, very difficult to see, but you can see the circular nature of where the blood supplies would have come in. I mean, it's going to be there, because I can see all of these other things. And that really is, I can't see anything that's not right here. It looks virtually identical to me, to what we see in the pattern of a human brain. That these are all the same thing, and that chunk comes off the back, and these fibers go up to the front, and this thing blobs off the back. There's nothing that's different. So that's all I can say. I'm not a genius at this. All I'm doing is looking. And the auditory canal is there as well on the other thing. Now see, here's where all those muscles invest over here. And I just don't see anything that's wrong. So, see, there's the auditory canal here. You come back on your own jaw, there it is right there. Nobody made this thing. This thing is just, it is what it is. You see that? Look close at the jaw, and you know, I just showed you that what, and I'll show you what the tendon investments look like, and you'll see it. You see this here? That's where things invest into bone, and they hold on, and they grab. And they're all around your jaw here, that what you would need to have to do this work. That's an investment of tendon. I'll show you that in a second. They call them Sharpie's fibers, I believe. And anyway. All right, this is a tendon in placement in the tibia insertion. You see all the little fibrils? See if I can come in a little closer on that. That's exactly the same situation you have in the jaw bone of the Mitchell-Hedges crystal skull. Now, these are, I can't see how anybody could have done what is in that Mitchell-Hedges skull. There is just nothing wrong. And this is a tibia, but it doesn't make any difference. Anywhere where your tendons and muscles invest heavily into the bone, you're doing a lot of work, and your jaw, as mine does, does a lot of work. So, you know, not only talking, I do a lot of eating too. All right, thank you. All right, this is a mud fossil head. Now, this was preserved in different conditions. It was down in the clay down in Kentucky. Jim Burchell was doing a research on it, and I worked with him, and Arlie Colville actually found the head. Now, you could see and I did a full autopsy on this, and there's no question it is a human head that was petrified. And it is now sandstone, which is SiO2, which is from the silicon in the skin bonding with the oxygen, becoming SiO2, which is sandstone. And that's what happens. Skin is 50 times more dense with silicon than anywhere else in your body. This is the ferrous oxides, the FeO2s and 3s, the red and the black, which come from the blood, fully, totally understood. I did the complete autopsy on it and found all of the vascularization, all of the bone foramen impressions. The irises of the eye have deteriorated. There is an actual crease in here. There's some form of a hat he has on here, it appears. And you can slide a playing card right up in between where the hat covers the head. There's a actual round crushing blow here that fractured his skull, and coming down through the center there's it appears to be a sword blade impression, and that is, we had a CAT scan done and it showed that. Now, And there's a video on this on my Mudfossil channel about the entire autopsy.